Hi everyone. Today we'll be learning about an identity which is slightly special. The identity itself is stated as below. X plus a, x plus b is equal to x square plus a plus b times x plus ab. Now the reason why I said it's special is because it is also in the form of a quadratic polynomial defined in x. Now what is this quadratic polynomial? Do I even really need to know it at clear in grade 8? No, not really. So let's just stick with the use of this identity, and maybe later in the video, if time permits, I'll explain how this defines a quadratic polynomial. Now, we've already learned that an identity is something which holds good or is true for all the values of the variable. That is, your LHS ends up being equal to the RHS no matter what value I substitute for x, a and b. Now let me just try changing the signs instead of the values. Okay, so instead of a plus, let me just try making it a minus and see what happens. So if this was x plus a times x minus b, on your RHS what you would get is x square plus a minus b times x minus ab. And what if I make both of them minus? So that's x minus a, x minus b equals again x squared. But this time you just need to pay attention that the minus is outside the brackets and it's a plus b, because since minus a minus b on the LHS, let's just take the common minus outside. So a plus b times x, and minus times minus is a plus, therefore plus ab. Now these are the variants of this particular identity. It changes depending upon your signs. Now the fourth one is similar to the second, which is x minus a this time times x plus b. Now the RHS, I'll leave it to you to fill it up. So what's the use of this identity? Let's see. Since it's a multiplicative identity, it has to deal with multiplication. Using this identity, we can evaluate the product of two numbers. For example, 46 times 48. Now, this 46 times 48 can be written in varied forms, right? As we mentioned earlier. For example, again, 60 minus 4 gives me 56. 60 minus 12 gives me 48. Or I could write it simply as 50 plus 6, or 50 minus 2, 48. So on for this one as well. Now if you notice, the first one has a minus and a minus, the second one has a plus and a minus, and the third is a plus and a plus. So I've written the same multiplication in three different forms. Obviously, all the three of them have to give me the same answer. If you notice, 60 minus 4 is easy to use, but 50 plus 6 times 50 minus 2, which is this one, is way easier. So I'm going to be using 50 plus 6 times 50 minus 2 to evaluate the value of 56 times 48. Now this is again of the form x plus a times x minus b, where my x is equal to 50, my a is equal to 6, and my b is equal to 2. Now x plus a, x minus b gives me x square plus a minus b times x minus ab, as stated before. So just directly substituting these values, x square is 50 square, a minus b, which is 6 minus 2 times 50, minus ab is 6 into 2, which is 12, and that again is 2500 plus 4 times 50, which is 200, and a minus 12, and on doing this I end up with a value which is 2688, which is actually the multiplication of 56 times 48. Now I can do the same thing using 60 minus 4 times 60 minus 12. So that's what I'm going to do here, and this is of the form x minus a times x minus b. So just quickly substituting for x 60, I get 60 square minus a plus b, where my a is 4 and b is 12. So 4 plus 12 gives me 16 times again 60, and ab is again 4 into 12, which is plus 48. This ends up with 3600 minus 960 plus 48, which on addition and subtraction, the final answer is 2, 6, 8, and 8. Same as the previous one. So now there's only one single identity, which is your basic identity, and that is x plus a times x plus b, which gives me x squared plus a plus b times x plus ab. Now, this is the basic one, and the others are all just variants on this one. And any multiplication can be written in any of these four forms. That's all there is about this identity. I'll talk about how this identity actually defines a quadratic polynomial in another video. Thank you so much for listening, and keep following. Bye bye.